All right, welcome everyone. My name is Casey Wang. I am a co-PI of the Fabric project. Thank you all for joining us today for our fourth episode of Mastering Fabric Tips and Tricks webinar series. Today I'll be led by Jim Griffioen and Charles Carpenter. Next slide, please. Before we begin, I'd just like to share a few housekeeping items. The webinar will include a live question and answer session right following the presentation. So please prepare your questions, but note that the chat feature has been disabled. So if you have a question, please open the Q&A box at the bottom of your screen, and we will answer the questions during the Q&A sessions. Finally, the webinar will be recorded, and it will be shared with all the registrants. Next slide, please. Today, we're joined by our presenters, Jim Griffioen and Charles Carpenter. Jim Griffioen is a professor in the computer science department at the University of Kentucky, and he serves as the director of the Laboratory for Advanced Networking and the director of the Center for Computational Sciences. His research interests include, among other things, future internet architectures, programmable networks, and network measurement and monitoring systems. He is a co-PI of the Fabric project. Charles Carpenter is a software and data specialist for the Center for Computational Sciences at the University of Kentucky. He works on the monitoring systems for Fabric's infrastructure, and he enjoys making it easy for users to add matrix gathering systems to their own experiments. He was also involved in developing the Genie desktop. He got his start with Matrix while creating biomechanics software for the thoroughbred industry. I will now pass on to Jim to start the presentation.
All right, well, thank you, Casey, for that introduction. And I'd like to welcome all of you to this installment of the Fabric Tips and Tricks series. Today, what we're going to be talking about is how to access and use the data that the Fabric infrastructure itself is collecting. And as many of you know, Fabric is a programmable network infrastructure that currently spans the US and also has international sites as well. And has roughly about 30 racks. Each of these racks has both hardware and as well as storage and network connection links and software that's running on each of these racks. And that software and that hardware is constantly being monitored by the Fabric operations team to make sure that the system is operating correctly. In addition to that, though, it's producing a wealth of data that the Fabric team has been making available to researchers and to experimenters for their use in their own experiments. So while many of you may have used Fabric for your research or for your teaching a class, you may not have given much thought to how might I possibly use the Fabric infrastructure data in my own research. So let me just give you a couple ideas of how people have been using it in ways that you may think about using it in your own research. So first of all, one of the areas that we often see some difficulty is when researchers are using an experiment and running their experiment and wondering why their experiment isn't behaving the way they would expect it to. And the question then becomes one, is there something wrong with my experiment, or is it the underlying infrastructure that's causing the problem? So one of the questions we get is, is the Fabric infrastructure operating correctly? And so it'd be really nice to understand, is there a network problem? Has a link gone down? It may also be that you're concerned about whether there's congestion that you're competing with. Is a particular link congested? Or is it possible that the host system that my VM is running on, has it become heavily loaded? And is that what's slowing down the performance of my VM? But basically, in the objective in many ways is just to try to understand what is going on with the underlying infrastructure and to know whether this is in fact affecting your experiment. In other cases, you may just want to run your experiment and see if it's actually being reflected in the underlying hardware infrastructure. So for example, if you're expecting that traffic will be going across the link between Salt Lake City, for example, and Starlight, you may like to see, while I'm running my experiment, am I actually seeing traffic being going across that particular link? Is it appearing where I'm expecting it to appear? Is it appearing at the levels that I'm expecting it to appear? So you can also look and be interested in looking at whether the load on a particular host is increasing, what kind of load you're affecting that particular host with as well. So there are a variety of different ways in which you might want to sort of see the impacts of your experiment on the infrastructure itself. In other cases, you may just want to know, well, can you help me find links that are lightly loaded, or can I have hosts that are lightly loaded that may be, or may have low jitter across a particular link? And we also have researchers that are just interested in knowing how the infrastructure is behaving and how are infrastructures like Fabric being used by the research community. So these are just some examples of ways in which you may find the infrastructure data that's being collected by Fabric of value to your own experiment. So Fabric, unlike many other research infrastructures, makes this data available. And it's done via it's made available to the community based on differing levels of trust. And so some of the data that we have is available to publicly to anyone. And there are other levels that depend on what your role is, either in Fabric or as a researcher in the particular project that you're working on. All right, so we actually collect the data into 4 different repositories that we make available to users. All right, so moving along, what's actually being collected? Each of the racks, in fact, is sort of a small private cloud. It has a series of worker nodes that are actually where the VMs run. It also has a head node that's doing the controlling of the software that's running on the worker nodes. In addition to that, we have switch hardware, we have storage hardware. We also have a GPS time signal that's coming into each of the racks and is driving a PTP time signal that gives very accurate timing to the events that are being recorded on the rack. In addition to that, there's software services that are running. We have OpenStack, we have Docker containers, we have a couple monitoring tools, we have the control framework, and many of these things are producing significant amounts of information that we are in fact collecting, and much being made available through the Fabric measurement services. All right, so what kind of things are coming in? We have basically a lot of numeric data coming in. We do have some logging data, and in some cases, we can actually get at packet data as well. What we're going to focus on today is mostly the numeric data, which is the vast majority of information that we have. And basically, the numeric data consists of the metric name, the identity, the value, the content that we're actually trying to record. So, for example, you may be interested in knowing the number of HTTP requests that are being issued. There may be some sort of label or some clarifying value as well that identifies, let's say, HTTP requests coming in with a code of 200, and then a value that is associated with that. In this case, let's say it's 1027, and a timestamp of exactly when that occurred. So much of the data that comes in has this basic format. And we are collecting all that data through a Prometheus system that periodically gathers these metrics and stores them into a time series database, which we then make available through a Grafana interface, and we'll also have the ability to allow you to access that through an API if that's of benefit to your research. So moving along, let me just quickly tell you a little bit about these 4 different collection services and 4 different repositories. The first one is what we call our public metric sites, and this is available to anyone. It does not require any authentication, and it has very basic link information, but link information that can be extremely useful to you when you're trying to debug and understand what may be affecting your experiment. So in particular, you may like to know what's the up-down status of a link, or what is the current link utilization. So we have link utilization graphs showing traffic flowing across links. That gives you some idea of the congestion that you might be encountering. That is often very useful and sufficient in many cases to sort of identifying the different potential problems that you may be having with your experiment. In addition to that, we have an infrastructure metric site, and this one contains additional information, drilling down a little bit more into what's going on in each of the nodes within the experiment. And in particular, it has things like CPU, memory load, disk usage, network loads. and can even give you information down to sort of the port level. And this information is available to all authenticated Fabric users. And this is a wealth of information with lots of data that is can help you not only debug your experiment, but also give you ideas of which hosts are heavily loaded and may help in designing your experiment in the first place. In addition to that, we have a research metrics site, and this allows you to get access to a very large amount of the Fabric data being collected. In this case, you would need to write a proposal, explain what the research is that you're doing, and in many cases require you to sign some sort of NDA and would require an approval process. And of course, then we also have the data site that we use for our operations team that is continually monitoring and measuring the data and making sure that Fabric is operating correctly. All right, so what kind of data do we measure? Well, we measure data both at the system level. I've mentioned this before. We have bandwidth information, packet counts, latency information, usage of CPU, memory disk, but we also have some information about the low-level optical data. This is being collected by our ESNet colleagues and has a great deal of information about how the optical channels are actually being used. And you may find that useful, particularly if you're doing work at the optical layer, at the lowest layers of the network. All right, so how do you find all this? Well, the place to go is to go to this first link that we're showing here, and this will bring you to a page where you can select from any of these resources that I just mentioned. You can either go to the public site or you can go to the infrastructure site. We have this optical data available, and another service that we have is our latency service and a soon to be added service, our persona measurement service. So let me say a couple things about the latency and persona measurement service as well. These are what we call our OWL and persona services, and these actually include active measurements where we actively probe the network. So first, let me begin with OWL. This is our one-way latency service, and the goal here is for us to be able to accurately measure the latency from one node in the network to another node in the network. And you can access it off of the page there with all of these different graphs that I mentioned earlier. Okay, so what happens there? If you go to the OWL service, you can go and in the right-hand corner, top corner, you can select a source node and a destination node that you would like to measure the latency between. And also you can show how far back in time you'd like to see what the latency measurements were that were being collected from this. And once you hit the submit button, it will actually go and grab that data and plot it for you, and also give you sort of a graphical representation of the geographic locations you're measuring between. This data can be very useful. It is highly accurate because it is using a GPS-based clock signal to be able to synchronize the clocks. So normally when you have an OWL service or a one-way latency service, if you were to measure the clocks and use the sending clock to timestamp the packet before it left, and then you were using the receiver's clock to timestamp the packet when it arrives, you cannot necessarily difference between them because those clocks are not synchronized. In fact, it's possible to even get negative latencies. So as a result, what we've done in Fabric and are able to do because the clocks are synchronized, there is a GPS signal that actually drives the clocks at each of the racks. We are able to take the sender's clock, timestamp the packet, and actively send probe packets to the receiving node, where we then again apply a timestamp, and we then difference between them to get very accurate timing between them. So if you'd like to find very accurate latency measurements across a particular link, you can use our OWL service for that. All right. This is using actually and built out of a long-lived experiment. It's actually an experiment running on top of Fabric that is continuously collecting this information. And this then calculates it, sends that information off to our public website where it's made available to you. And you can find that information at the URL listed here. All right, in addition to measuring latency across the backbone, another thing that we like to understand is what's the achievable bandwidth that we can get in an experiment. So we were also running a long-running persona experiment where we're measuring the bandwidth across the data plane. And basically, we are running the well-known Personar tool that's often used in many network experiments to measure bandwidth. And that is collecting information that is then sent off to a archive service where we run it through a Logstash system and place it onto our public metrics site. And this is operational, but not yet on the site. We will be there shortly. And once it's there, what you will see is that they have the Personar Mad Dash grid. This is a very helpful grid to be able to quickly see what kind of performance you're getting between any of the two racks that you would like to see. So the matrix there shows from a source rack to a destination rack and the performance that you're currently getting through that. You can click on any one of those nodes and it will give you a drill down to give you much more detailed information about what is going on in terms of the bandwidth and the throughput that is achievable over that particular link. So in addition to the previously mentioned passive measurements, both the OWL service and the Personar service allow you to take some active measurements of what you're actually able to achieve in Fabric. So with that, I'm going to actually turn over the presentation now at this point to Charles Carpenter, who will give a short demonstration on how to use the services I just presented.
Thank you, Jim. Okay, I am Charles Carpenter. I'm with the University of Kentucky. I work with the Fabric team to develop systems that monitor the Fabric infrastructure and also things that will monitor your slice. As with most things, if you want to start looking into this, you can go to the Fabric portal, which is this portal.fabric-testbed.net. And if you scroll down here, you'll see a map of the resources that are available. This map has all the high-speed data links that connect all the different sites, and it has all the sites throughout the Fabric network in the US and across the world. If you hover over one of the sites, you can look to the right, and you can get some extra information about the total resources that exist on the site and the amount of resources that are available currently. So that can give you an idea of how loaded a rack is, or if you need to go figure out where I can get a GPU that's available. What this doesn't show is it doesn't tell you really anything about what's happening inside the nodes or what's happening in between the racks throughout the network. So to see that information, we can go up to the resources button or tab and click on the monitoring and measuring tools. And here we will have several links that take you to different monitoring tools. We have the public metrics, which, as Jim just mentioned, is the most available metrics. These are the ones that we don't mind anybody seeing. You can go to the site, you can log on, and you can see these information just as anybody. Actually, you don't have to log into this site. Anyone can go visit it. Then we have the infrastructure site, which is more of the metrics that are available. And this one is only limited to Fabric users. So you have to have a Fabric account. When you go to this site, you will log on, and then you'll be presented with a much larger set of data. There's also the optical data hosted at ESNet. We have a link to that. And we have a link to our Fabric latency monitor, which Jim was just referring to. So I'll start off as going to the public metrics. We go to the center, we find the open tool button. And that will pop up a new window that has the Grafana interface. In the future, this will actually go to the landing page. Right now, there's a link that will take you to the landing page. And this is what it looks like when you just go to the public-metrics.fabric-testbed site. We have several links right at the beginning. One is the Grafana link. It goes straight to the Grafana interface. If you're familiar with Grafana and you've used it before, you may be comfortable just going to this, and then you can look through whatever dashboards are available and use it as you normally would use Grafana. But we've also created other dashboards that have links that go straight to them, and we have a little bit of information about them. And we'll be adding more help data to these. So what I want to show first is the link traffic graph. Remember the map I just showed you? This is showing you the traffic that is going between all the nodes and all the sites. You just click on that, and anyone can see the site, so you don't need to log in. It'll just appear. And what this traffic is showing is the traffic from all the interfaces on all the nodes to all the nodes that they're connected to. So if you can imagine that is a lot of data. If you look at here, we can scroll down and you basically see a list of all the interfaces on all the node servers that connect to each other on the data plane link. If you want to narrow that list down because this is too much information, you can pick this maybe Atlanta. And by clicking on one of these, it will just show that single entity. So that makes it easy to see what happens. Atlanta is connected to Dallas. We look at another Dallas to Atlanta. You can control click on that. That'll bring up another one. And so forth. So you can just continue to click to see whichever information you want. And when you're done with that, you can click anywhere, click on this selected, and it goes back. As you can see, there's a lot of data, a lot of sites. One problem with this is that if you're looking at multiple sites and you have one with a large data flow, the scaling of the graph will make it so that all the other data flows just look trivial and you can't really see what's going on. So one thing we can do is we can use the Grafana variables. Grafana is set up with these dashboards, and the dashboards are basically sending a query in the back end to get the information. And these variables let you customize the query. So for this one, there's a drop down for the source rack, and let's just clear all those. And we can click on Atlanta, and let's click somewhere else. And now what it does is just showing the interfaces that are connected to Atlanta. So now you can see that Atlanta is connected to Dallas, Washington, Star, etc. If we just want to go back to even reduce that more, we can click on the destination rack, clear that, and we'll just do Dallas, click somewhere else. And now that's just showing us the data that is going between Atlanta and Dallas. These are the interfaces that are on the machine. So Atlanta has an interface with number 3000, has data coming in from Dallas, and it's sending data out to Dallas. If you just want to see that one, you can see that. You can click on the outgoing data, and you can see here a lot of data is coming in from Dallas, but not much is going out. You click on Atlanta, and then you go to the corresponding Atlanta to Dallas. Try that again. You can see that the data that is leaving Atlanta or is leaving Dallas is coming to Atlanta, and it's pretty much symmetrical, which for the most part it should be. Again, we can click that and go back. Another way that you can query down and narrow the data that you're seeing is through the time mechanism. Up here is the little clock icon. It's showing you that we're looking at the last hour of data. We click on that. We have a choice on the right, which will give us relative time frames. This is the data that's coming from now to however far back. We click on 5 minutes, it will show us the data from now back 5 minutes. And when the data is zoomed in like this, you can see every data point. The data is collected every 30 seconds in general throughout the Prometheus system. So anything closer to or smaller than 30 will not really help you much. If you look at the refresh up here, you can click on that and it will automatically reload. So you can click every 30 seconds and it will reload the screen every 30 seconds. So if you have an experiment running, you can select which racks you're interested in and which links you're going. And as this experiment runs, you can see the data pop up on this graph in pretty much real time. You can choose this from 5 minutes, and you can go all the way up to yesterday's, weeks, months, years. We also have the ability to do an absolute time range. So if you did an experiment and you knew you did it earlier, say you did it last Monday, and we say Tuesday, you can select that time, and it will fill in the absolute time range. This gives you the exact year, date, month, and then down to the second. You can see what the time range is. One thing I do want to mention is that the clocks on all of the servers are synchronized to UTC time. We're using GPS data and the PTP to keep it very accurate and synchronized throughout all the machines. This browser, when you use that in Grafana, you can select it and have it set everything to your time, so it makes it a little easier to figure out what's happening or you can change that to UTC time. If we apply that time range, we can see what was happening last week. If, for example, in this time you wanted to go back and you say, well, this is the experiment I was running, let's zoom in on that. So you just click and drag over that, and it will zoom in, and you can see the traffic that was happening. You can further zoom in some more. And now you have a nice little compact area that is showing what happened to your experiment in that time. Now, once you've done that, you'll notice it fills in the exact time and date up here. But the other nice thing about this is it actually encodes all this information into the URL. So now the URL holds the all the variables that are creating this graph. It knows that you want Atlanta as the source, Dallas as the destination. It knows that you want this exact time frame, and it can save that. They also have a feature where you can easily share that. You can customize a little bit and then just copy the URL. So if you're working with somebody, you want them to look at this graph, or you want to just save this graph for later, you can just copy that and put it into your notes. So let's go back to the public metric site. We also have the current link status, which is the similar data, but one of the beauties of Grafana is you can take the same data and you can present it in different formats with different panels and different viewpoints. This one just has some different ones. I'll let you explore those on your own. And then we also have links to the one-way latency and the ES network. But let's go back to the Fabric portal. Now we'll look at the infrastructure metrics. The infrastructure metrics is the site that you are required to log into. If you click on the open tool, if you're not logged in, it will go to the login page. If you are, it will go to wherever it thinks it's going. In this case, it's going to Grafana. Again, we'll be changing that link to the landing page. So here it says in the middle that I'm logged in. When you log in, it's the same as logging into any other Fabric service. It's just the CI login. And here we have the same two graphs that we had before, because this site has all the data that the public site has, but even more data. Then we have several different graphs that you can click on to go to. One I want to show is the detailed node measurement. The data that we're gathering with the system is gathered by a system called Prometheus. And Prometheus works on the idea of having exporters, where you install some software on your machine, and then that software will make a server available that our central data collection can call and say, let me have some data, give me have some data. So it pulls for the data. In this case, this is the node exporter, which is a very common one that is designed for a Linux or Unix type machine, and it will give you a massive amount of data that you kind of think of what you can get from doing commands on a Linux machine. You can get some general information. You can see how many cores on the machine, how long it's been up, total RAM. You can see the CPU, how busy it is now, what the system loads are, what the RAM usage is, and such. And then for the rest of the page, we have a very long list of many graphs. These are in rows that you can collapse and open. So if you know which ones you want, you can collapse them and kind of ignore those. But it starts off with just a basic overview. Up here at the top, we have the CPU and how busy it is and all, and you can see that as a graph that is just the instant values. Down here, you can see the values over time. If you go down, you can see information about the memory. You can see network traffic, the different interfaces. One thing I can mention here is that the network traffic that we saw in the earlier one is gathered through SNMP, and it refers only to the data plane networks, the main connections that connect one rack to another rack. This refers to all the connections that are inside a server on the rack. As you can see, there's a whole long list of them, and it's kind of hard to see what's happening. When you want to view a graph in more detail, you can go up to the three dots up here, click on that and do a view. And then when you do that view, it zooms in on that and it gives you a nice list down here that you can look through much easier. And you can also sort that and find out, you want to know what the max thing is or whatever values are in the particular graph. We also have memory information. And we have a memstat, vmstat, which is pretty much the same information that you're used to getting when you run a vmstat command. You can get the pages in and out, page faults, things like that. Information about whether the time is synced, system processes, miscellaneous. You can get disk writes. You can look at the storage file system, see how much data, what the max possible data is in there, how much of it is being used, how much is available. Again, you get the network traffic, but you can get more than just the traffic. You can also get the packets that have been dropped. You can look at multicast and things like that. This is a section that has a summary of different network data. If you scroll down further, you can get network SOC status. Then you get netstat. You can see the in and out of ICMP, and so on. You can see TCP connections versus UDP connections, and so on. So you can see that there's a huge amount of data that is available here. And one of the problems that we have in the system is that there's so much data, people often get lost and don't really know where to start. So that's why we've kind of made these other simplified dashboards that kind of focused on one thing. One thing I'll show you quickly is the rack health information. What this is doing is it's taking the information that you just saw from the node exporter details, and it's just showing it for each rack, and it's just showing a certain aspect of it, showing the CPU load and the RAM usage. Because if you know what the CPU load and the RAM usage is, you get an idea of how heavily used the rack is. The previous one, you only could see one machine at a time. With this dashboard, you have a drop down where you can pick which racks you want to. So you could pick Atlanta and CERN, for example, if that's where your experiment is running. And then you can have this up and you can see what's happening. This also does have the live update, so you can run that and it will refresh it. As you run your experiment, you can see if you're affecting memory, or you can see if you shouldn't be affecting memory, but the memory spikes mean someone else is taking your memory. One thing I also want to mention is that the racks, as we saw in a previous picture, each rack has a head node, which is kind of the controller, and then it has several worker nodes. The worker nodes are where your experiments are running. In this case, Atlanta has 2 worker nodes, worker 1 and worker 2. The head node is the site name and the dash head node. And the CERN rack has 6 nodes in it. And again, the worker nodes are where your experiment is running. So those have several similar ones. We've got the basic node measurements where we've picked out a few of those values, and you can compare them between racks as well, or machines. We have the same thing with the load per node and the RAM usage. One other thing I want to show you is the measurement examples of how to explore the set of available metrics. We click on that, it will take you to the metrics explorer. You can also get there by using the 3-bar menu, and it's under Explorer and Metrics. You click on a new metric exploration, and that will show you a graph of all the metrics that are out there. So there are literally thousands of different metrics out there. We were using the data plane in previously, but you also have other ones. You have IF connector present, IF octets in. And you could, if you don't really know what that is, but you think, well, maybe I'm interested in octets, you can hover over the little I, and it will give you a help string. These help strings vary depending on who wrote the exporter and what's in there, but often you can find just a little tidbit that can tell you a little bit more about it. This one says it's the total number of octets received on the interface, including framing characters. And then it gives you the OID number. This information is taken from an SNMP exporter, And so if you really want to know exactly what that data is coming from, you can look up the OID and get even more information about it. So we can also select one of these. Let's look at the data plane in bits. This is the information that we're using to show the first that we saw in the first graph. When you see that, it kind of gives an idea of what's happening just in general. And it gives you a list of labels. As Jen mentioned on the earlier slide, that each metric has a name, and then it has several identifying characteristics that are defined by labels. Those labels help filter down to the information that you want. If we go to the breakdown tab, we will basically see a list of all those filters, and it kind of shows a graph form of those. So we know how we set the destination filter earlier. So let's select the destination rack. And this will show you all the possibilities for the value of that label. In this case, it's basically one for every rack out there. You have LBL, Kansas, etc. And once you've also chose that, you can also go to related metrics. And this is really handy because you may see the data plane total bits, but you're thinking that's not quite what I want, but I want something similar. What else can I get about the network? So this is showing you several values that relate to the network. You have the octets in and out, you have unicast packets, node load, because yep, puts a load on the machine, etc. So this is a very useful tool that you can use to drill down and explore the metrics, looking for things that you don't know if they're there or not. You can also do a search metrics and then type in things like, if you want network, you can type in network in there. So the last thing I want to be able to show you is the one-way latency. We can get there by clicking on the latency. There's links to it on both the portal site, the research site, I'm sorry, the portal, the public, and the infrastructure site. It's a very simple, intuitive interface. You have nodes, so you can have star, and we can look at that between that and Massachusetts, maybe. And you'll present it with a map that has a route, shows you where they are. You can actually find out in detail. And then it shows you what the latency is over the time span that you've picked. These are in milliseconds, so there's about 13 milliseconds up and down. If you want to look at a larger time frame, you can look at an hour, submit that. And you can see that it's pretty consistent. The graphs are centered around whatever fits on there, so we don't take it from zero, so you can see the fine detail. We want to do from Massachusetts maybe to CERN, which is across the ocean. So we would expect a much higher latency, and indeed it is 60. But again, it's still pretty consistent. We have found sometimes that the latency is actually a little bit different going each direction, which is interesting. So if you run an experiment and you wanted that data, you can also just download the CSV, and it will give you a file that shows the data that you're seeing in tabular form. So you can then work with that however you would like to. So that is the basics of how to navigate the websites that we have. So now I'll go ahead and toss it back to Casey.
All right. So now we'll move on to the Q&A session portion. We'll start to answer questions that are submitted during the presentation. We'll now stop screen sharing to begin answering those questions. The first question for our audience: prior to actually initiating the data transfer, can I run a query just to get expected elapsed time for transferring a certain set of files from one point to another?
Yeah, I'll go ahead and take that one, Casey. So to estimate file transfer, we don't have any metrics that are measuring file transfer times. We can, though, tell you an estimate of what we've seen in the past regarding what the bandwidth is. We can tell you things like latency, to put together a model based on that to come up with some estimates, but we don't have any mechanisms that predict what the file transfer would be. You can, of course, run a file transfer, and you can do the timing within your own experiment to see what the amount of time it takes when you actually do run the transfer.
All right. Now the second question, can I monitor the estimated energy consumption of the VMs during the runtime? If so, is there any breakdown for the different components, CPU, memory, disk, network? If there's no such capability, will there be any?
I'll pass that one to Charles. We do have very limited power measurements, but go ahead, Charles.
Yeah, we do have very limited power measurements. We kind of know how much power the rack is using overall, but we don't really have that broken down by sites or by machines. One problem is with the VM, it gets really complicated in trying to figure out what an individual VM is using. So that is a difficult problem to solve at the moment.
So the third question, can you give some situations where experimenters might want to look at or use the fabric infrastructure matrix data?
Sure. So as I mentioned in my introduction, we often see that users are very interested in knowing what kind of performance a particular link has, both before they choose or design an experiment to understand its capabilities and to understand its expected performance over time, as well as to see what's actually happening when they're running their experiment. So looking just at that public metrics site can often be very useful in terms of just seeing what is going on with the link that they are expecting to use. That is one of the really common uses that we've been seeing for the metrics site.
The next question, can I access the fabric metrics data from my Jupyter Hub notebook?
Yes, you can. The data is accessible via a REST API. For our previous NIT, we actually did a demonstration of how that is possible, so you can look up the notes for that. But it would be very simple just to write a API that does a REST call, and once you know what the queries are needed, it's pretty straightforward. The next
question. Okay, go ahead.
The key is currently just you use the fabric key that you go to the credential manager and grab that key.
And I assume there should be a Jupyter example that the user can find.
Yes, we'll have to point that out in the Jupyter examples under public demos for NIT9. There's an example notebook of how to do that.
Thank you. The next question. You mentioned an API interface to the data. When should a researcher use the API interface rather than the graphical interface? How does one get and use an API key? I guess you just answered that question. All right. Next question. Can you say more about the Metrics Explorer? How do I find the list of data that is available in Fabric?
The Metric Explorer will show you basically all the metrics that are available. There's another part of it that I didn't show you, which is just the normal Explorer. So the Explorer or the Metrics Explorer that I showed you has the kind of the graphical way, and you can type names in there, and it will kind of help you drill down. But there's another Explorer in there where you can just type in, if you go to it, you can just type in a few characters of what you're looking for in network, and it will pop up a big list and show you what's there, and it can actually fill in a query for you and show you how the queries are built and kind of guide you in what values are available for the labels, similar to the graphical one that I showed you.
The next question I think is related to an earlier one. Is there any way we can get the power of the rack where the VM is running?
Yeah, we currently have very limited data on that. The power systems that are used on the racks are varied, and they vary on what they make available. So we have kind of a mixture of data on there. And again, the data is largely just how much power the whole rack is using more than how much each individual server is. So it makes it really difficult to figure out what an individual VM is using.
How far back in time can I request data?
In theory, we will be keeping the data as long as we can, but as far as being able to access the data, we would say that about 3 months you should be able to easily access that. On the public site, since there's less data, you can go back a little bit further easier. And if you need data further back than that, then you may need to make a special request for that.
And now the last question. What is the difference between the Fabric metrics sites and MFlib, the Fabric Experimenter Measurement Library?
So if you used MFlib, you know, when you set up your experiment, it creates basically a measurement system on there, adds a node on there, and that node adds exporters and grabs data from the different nodes in your experiment. And that is all specific to just your experiment, and no one else can see that, and it just exists as long as your experiment is running. The infrastructure metrics is very similar in that we have a central server that is gathering all the data from Prometheus and collecting it, except that we're grabbing a massive amount of data, and we're always doing that. The data contains a huge amount of information, some of which we're making available to you.
All right. Well, thank you very much, Charles. That's all our questions. Thanks again to our speakers, Jim Griffioen and Charles Carpenter today. And so next slide, please. In addition to our speakers, we'd like to also acknowledge a team behind the scenes helping to make this webinar happen. It's Casey Wang, Chelsea Davis, Jay Shree on the Fabric team. And thank you all for the audience for participating in today's webinar. In addition to the recording of the webinar, we will also email everyone a list of resources. The slide deck will be shared, and there should be a form for connecting with us. We hope you will stay connected with the Fabric team for more questions and support. So going forward, we have more webinars coming next month. The first one, Mastering Fabric Tips and Tricks webinar series on November 25th at 3 p.m. Eastern Time. And the Stitching Together Innovation with Fabric Users on November 26th at 2 p.m. Eastern Time. Both webinars will be focused on facility ports, with the November 25 focus on existing Fabric users, and November 26th webinar focus on new users use case. We would appreciate it if you can forward the information to relevant users in your community. And as a final reminder, please submit your Fabric matrix if you are a Fabric user, and make sure your project abstract in the portal is up to date, because we'll use that information to outreach as well as promoting your research on our website. Thank you again, and have a wonderful day, everyone.